Hello everyone, welcome back to my channel. So today we are seeing rational numbers part 6. So we have already completed part 1, 2, 3, 4 and 5. So in which we have seen what are rational numbers and the properties of rational numbers, that is the property of closure, commutativity, associativity and distributivity. So today we will see the role of 0 and role of 1 in rational numbers, and we will also see the reciprocal of rational numbers. So let us start with role of 0. Now look at the following equations. So here you can see 2 plus 0, that is equal to 0 plus 2. So equal to how much? 2. So here 2 is a whole number and 0 is also a whole number. Okay. So if we are adding 0 to a whole number, we are getting the same whole number. So addition of 0 to a whole number leads to the number itself. Okay. Similarly, let's see another equation. Minus 5 plus 0. How much will it be? It will be equal to minus 5. Similarly, 0 plus minus of 5. Again, this will be equal to minus 5. So minus 5, what type of number is it? It's a negative integer. So if we add 0 to an integer, whether negative or positive, if we add 0 to an integer, then we will get the same integer. Okay. Now let's see a rational number. So 2 upon 5 plus 0, what it will be? Again it will be equal to 2 upon 5. Similarly, 0 plus 2 upon 5 will also be equal to 2 upon 5. So addition of 0 to a rational number leads to the same rational number. So in general we can say that if a is a whole number, then a plus 0 will be equal to 0 plus a, that is always equal to a only. Similarly, for integers, if b is an integer, then we can say that b plus 0 is equal to 0 plus b, that is equal to b. And if c is a rational number, then we can say that c plus 0 is equal to 0 plus c is equal to c. Okay. Now let's draw a conclusion from here. So 0, as we are adding 0 to any number, we are getting the same number. So that is why 0 is called the identity for addition of rational numbers, of whole numbers, as well as for integers. Okay. So it is called as the identity for addition of any number. Okay. I think it's clear now what is the role of 0. Now to see the role of 1, we will see some of the equations. Here I have taken some equations. So first we will see the equation where I have taken the whole number 2 and I have multiplied it with 1. So 2 multiplied by 1, that is equal to 2. Similarly, if I multiplied 1 with 2, then also I will get it as equal to 2. So this shows the multiplication of 1 with a whole number. So what are you getting? You are getting the same whole number when you are multiplying 1 with the whole number. Now let's see for an integer. So here I am considering a negative integer, minus 5. So minus 5 multiplied by 1, what it will be? It will be equal to minus 5. Similarly, 1 multiplied by minus 5, that will also be equal to minus 5. So here we can say that when I am multiplying an integer with 1, I am getting the same integer. Now let's see for a rational number. So 2 upon 5 multiplied by 1, again that will be equal to 2 upon 5. Similarly, 1 multiplied by 2 upon 5 will also be equal to 2 upon 5. So here we will draw the conclusion that in general, if a is a whole number, then a multiplied by 1 will be equal to a, and again 1 multiplied by a will also be equal to a. So if I am multiplying 1 with a whole number, then I am getting the same whole number. Similarly, if b is an integer, then b multiplied by 1 will be equal to 1 multiplied by b is equal to b. So again, if I am multiplying 1 with an integer, then I am getting the same integer here. Similarly, for rational number, c multiplied by 1 is equal to 1 multiplied by C is equal to C. So if I'm multiplying 1 with a rational number, I'm getting the same rational number. Okay. So here we can say that 1 is the multiplicative identity for rational numbers as well as for whole numbers and integers. So this is the role of 1. So 1 is called as the multiplicative identity. Now next we will see the negative of a number. So what is the negative of a number? So here I am considering one number, suppose 2. So 2 plus minus 2, what it will be? It will be is equal to 2 minus 2, that is equal to 0. Similarly minus 2 plus 2, that will also be equal to 0. So what we can say is 2 is the negative or additive inverse of minus 2. It means what? So I am having this number 2. So negative of 2 is minus 2. Okay. And we can say it as the additive inverse. Additive inverse means if I am adding a number with 2 and I am getting it equal to 0, the sum is equal to 0, then that number is called as additive inverse. So here if I add minus 2 with 2, then I will get it as equal to 0. Okay, I can write it like this also. 2 plus minus of 2 is equal to 0. So this minus 2 is known as the negative of 2 or additive inverse of 2. Okay, so here we can consider, in general, for an integer a, we have a plus minus of a is equal to minus a plus a is equal to 0. Okay. So a is the negative of minus a and minus a is the negative of a. Okay. So I think it's clear now. Now let's consider for rational numbers. So here one thing you can notice here that I have directly considered integer, not the whole number. Why? Because in whole numbers we don't have the negative numbers. In integers only we have the negative numbers. So that is why we are considering integers and we are not considering whole numbers. Okay. So now coming to this rational number. So 2 upon 5 plus minus 2 upon 5. So this will be equal to how much? 2 upon 5 plus minus of 2 upon 5. So this I can write as equal to 2 upon 5 minus 2 upon 5. That will be equal to 0. I write minus 2 upon 5 first, then I will add with 2 upon 5, then also I will get it as equal to 0. So here again I can say that the rational number 2 upon 5 is additive inverse of minus 2 upon 5 or negative of minus 2 upon 5, or I can also say that minus 2 upon 5 is the negative or additive inverse of the number 2 upon 5. Okay. So now in general I can say that for a rational number a upon b, we have a upon b plus minus of a upon b is equal to minus of a upon b plus a upon b is equal to 0. So a upon b is the additive inverse of minus a upon b and minus a upon b is the additive inverse of a upon b. I think it's clear, because when you are adding minus a upon b with a upon b, then you are getting it as equal to 0. So that is why minus a upon b is the additive inverse of a upon b. Similarly, if I am adding a upon b with minus a upon b, then I am getting it as equal to 0. So that is why a upon b is known as the additive inverse of minus a upon b. So this is what the negative of a number is. Now let's see the reciprocal of a number. Now here suppose I have the number 2 upon 5. So by which rational number would you multiply 2 upon 5 to get the product equal to 1? Here we are considering this number 2 upon 5. So 2 upon 5 multiplied by which number? Suppose I am taking a number a. So this is equal to 1. So I have to find the value of a. That means with which number if I multiply this 2 upon 5, then I will get the product as equal to 1. So how to find the value of a? For that I have to take this 2 upon 5 from LHS side onto the RHS side. So here you can see that 2 is the numerator on LHS side, which will be the denominator on the RHS side, and 5 is the denominator on the LHS side, which will be the numerator on the RHS side. So I can write this equation as a is equal to 1 multiplied by 5 upon 2. So what it will be? It will be equal to 5 upon 2. Okay. So here I found the value of a is equal to 5 upon 2. Now 2 upon 5 multiplied by 5 upon 2. So how much it will be? This 2 will cancel out and 5 will cancel out. So here I am getting 1. So that is why this number 5 upon 2 is known as the reciprocal of the number 2 upon 5. So what is a reciprocal number? So I can say that for a rational number, suppose the number is c upon d. So this c upon d is called the reciprocal or multiplicative inverse of another rational number a upon b if a upon b multiplied by c upon d is equal to 1. So multiplying two numbers a upon b with c upon d, that product should be equal to 1. Then I can say that a upon b is the reciprocal of c upon d and c upon d is the reciprocal of a upon b. I think that is clear now. Now let's move on to the rational numbers between two rational numbers. Now you have seen the whole numbers, like we know that whole numbers are starting from 1 and they are going up to infinity. So between two whole numbers, suppose I am having 2 and 7. So how many whole numbers are there? I have 3, then 4, 5, 6. Okay, so these are the whole numbers between 2 and 7. Similarly, if I am considering integers, suppose I am considering minus 5 and suppose 2. So minus 5 is a negative integer and 2 is a positive integer. So how many numbers are there between these two numbers? Then I can say that is minus 4, then minus 3, minus 2, minus 1, then 0, then 1, then 2. So these are the numbers between minus 5 and 2. Now for whole numbers, we can say what are the numbers between two whole numbers. Similarly, for integers also we can say what are the integers between two integers, that also we can say. So now we will see what will be the rational numbers between two rational numbers. So here you can see the number of integers between two integers is defined. Definite number of integers are there. Similarly, for whole numbers also there are definite number of whole numbers between two whole numbers. Now let's see for rational numbers. So here we are considering 2 upon 5 and 8 upon 5. So you can say that between 2 upon 5 and 8 upon 5 we will have the numbers like 3 upon 5, 4 upon 5, 5 upon 5, 6 upon 5 and 7 upon 5. Okay, so these are the numbers which are lying between the number 2 upon 5 and 8 upon 5. Now let's see this 2 upon 5. Can I write it as equal to 2 into 10 divided by 5 into 10. So here I am multiplying 10 in the numerator also and in the denominator also. So it is remaining same. So this will come as equal to 20 upon 50. Similarly, this 8 upon 5 can also be written as equal to 80 upon 50. Okay. Now, so after this 20 upon 50, what are the numbers which I have? Like 20 upon 50, then after that I will have 21 upon 50, then 22 upon 50, then 23 upon 50. So likewise I will go up to 80 upon 50. Okay, so these are all the numbers which are lying between 2 upon 5 and 8 upon 5 only. Now again, let's see another thing. So 2 upon 5 can also be written as 2 into 100 divided by 5 into 100. So this can be written as 200 by 500. I can write it like this also. 2 upon 5 is equal to 200 upon 500. Similarly, 8 upon 5 will again be equal to 800 upon 500. So now you can see that 201 upon 500, then 202 upon 500. Similarly, this will go up to 800 upon 500. That means in between you will have 600 upon 500, 650 upon 500, 700 upon 500. Like that, so many numbers will be there. So here what I want to tell you is we can't have definite number of numbers between two rational numbers. So that means if you are given two rational numbers, 2 upon 5 and 8 upon 5, and if I say that write all the rational numbers which are lying between these two numbers, then it will be not possible to write all the numbers because the numbers are not definite. Okay, there are so many numbers, countless number of numbers that can be written between these two numbers. Okay, so between any two rational numbers, the rational numbers which are lying are countless. So that is the main thing which you have to remember. For whole numbers and for integers, there are definite number of numbers between two whole numbers or between two integers. Okay, thank you for watching my video. Let's meet in the next video. If you have any doubt, then please let me know in the comment section.